The objective for this lesson is to sort shapes based on self-determined sorting rules. In previous lessons, students practiced measuring angles, identifying parallel and congruent sides, and examining the attributes of two-dimensional shapes. In this lesson, we will use all of that experience to create sorting rules for a variety of shapes. Here we have 8 different shapes we will be sorting in this lesson. We will look at the number of sides, any parallel or congruent sides, as well as the number of degrees for each angle. This is our first shape. It has 3 sides, none of which are parallel, but all of which are congruent with each other. Using a protractor, we can measure each of the 3 angles to be 60 degrees. The most specific name for this shape is a triangle. The next shape we will examine has 4 sides. All 4 sides are congruent, and opposite side pairs are parallel. The 4 angles are each a right angle measuring 90 degrees. We will mark them with a square, the symbol for a right angle. The most specific name for this shape is a square. The next shape also has 4 sides. Opposite sides are both congruent and parallel. Opposite angles are also congruent. The acute angles measure 70 degrees, while the obtuse angles measure 110 degrees. The most specific name for this shape is a parallelogram. This next shape has 4 sides with opposite sides parallel. All 4 sides on this shape are congruent. Using a protractor, we measure the angles to be 50 degrees for the acute angles and 130 degrees for the obtuse angles. Here, opposite angles are again congruent to each other. The most specific name for this shape is a rhombus. This next shape has an irregular design. It has 4 sides, but none of the sides are congruent or parallel. As we begin to consider the angles on this shape, it is important that we measure them. One angle in particular may appear at first glance to be a right angle, but upon measurement actually measures 105 degrees. The most acute angle measures 35 degrees, and while the remaining 2 angles may not necessarily appear to be congruent, they each measure 110 degrees. The most specific name for this shape is a quadrilateral. The next shape has 4 sides, with opposite sides parallel and congruent. Measuring angles, they are each a right angle, 90 degrees. The most specific name for this shape is a rectangle. This shape again has 4 sides. We can easily identify the top and bottom sides as parallel. But what may not be immediately evident is the congruence in the length between the top side and the non-parallel sides. We can discover this by measuring each side with a ruler and proving they each have the same length. Measuring the angles, we can identify the uppermost angles as 120 degrees and the lowermost angles as 60 degrees. The most specific name for this shape is a trapezoid. The final shape is another irregular shape with 4 sides. No side is congruent or parallel with any of the other sides. Using a protractor, we measure the angles as 40 degrees, 105 degrees, 110 degrees, and 105 degrees. This measurement identifies one pair of congruent angles. The most specific name for this shape is a quadrilateral. Now that we have identified the attributes of each shape, we can begin to sort them. It would certainly be simple to sort them based on direct attribute comparisons, such as the number of sides. Or we could separate them by the presence or absence of right angles. But we also want to sort them using less obvious attribute characteristics. For example, we could place shapes with only one pair of congruent angles in one group, and those with more than one pair of angles congruent in another group. We could even create a third group for shapes in which all angles are congruent to each other. Or we could sort into multiple groups by the quantity of obtuse angles. The number of ways we can sort these shapes is large and varied. Students will almost certainly think of many sorting rules we have not discussed here. The objective for this lesson was to sort shapes based on self-determined sorting rules. We met this objective by identifying shapes and their attributes. We then created several sorting rules based on the attributes identified.